Sis, kita nak jalan ni?
Nak buat segmen TPP lah.
Lah, ya ke? Sekarang ke?
Lah, iyalah, tak salah.
Mama said, don't give up, it's a little complicated, all tied up, no more love, and I'd hate to see you waiting. Had to have high hopes for a living, shooting for the stars, but I couldn't make a killing. Didn't have the time, but I always had a vision, always had high hopes.
Hi, my name is Rosnella Majus and I'm going to explain to you about the introduction of radiation heat transfer. Okay, first and foremost, what is heat transfer? Okay, heat transfer is the movement of heat energy. For your information, heat energy can be transferred from one place to another place through three methods. Okay, what are these three methods? Okay, the first one is convection, and the second one is conduction and radiation, and the third one is radiation. Okay, conduction specifically done in solids, convection is in fluids, which are liquids and gases, and radiation, which required objects or does not require object. Okay, for your information, these three methods, which are conduction, convection and radiation, can best be shown through this method here, through this picture, which are heating a water in a kettle on a stove. Okay, firstly, the heat from the stove, which are the fire, will transfer to the kettle via conduction that I told you just now, which are conduction done through solids, which are the heat will transfer to the kettle. Then the second one, the heat will be transferred to the water via convection, which are in fluids. Convection is in fluids, which are liquids and gases. And the third one, the heat in this process will spread to the surrounding or the kitchen through radiation. Okay, for your information, radiation is a heat transfer that does not rely upon any source contact between the heat source or the heated object. So for example, the radiation is we can feel the heat from the sun without even touching it. That is the example of radiation. So for your information, this video will explain more thoroughly about the radiation heat transfer. Therefore, that's all from me. Thank you, bye.
Hi, so I'm Nazarifah Suraya and I'm going to explain more further in details about radiation heat transfer. So radiation heat transfer in definition is due to emission of electromagnetic waves. On my left is a table of the types of electromagnetic waves. As you can see, there are so many types, but mainly radiation heat transfer happens in the infrared region. Radiation emitted by a body is a result of thermal agitation by its composing molecules. So, radiation can also be described as a reference to the black body, but the black body thing will be explained more truly in the next slide. Radiation heat transfer is the only mode out of three that which the three is conduction, convection and radiation. The radiation is the only one of these three that doesn't require any material or medium for transport. It can even cause a vacuum. All objects emit, absorb, or transmit radiation. Obviously, heating an object will make it radiate more energy because radiation is a heat transfer. So, one thing for sure is that a dark dull surface will emit. A dark dull surface is a better emitter than a shiny one. That's all from me. So, for the next topic, let's go outside.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nabil Haikal bin Rizwan, and now I will present to you the properties of radiation. But before we know the properties of radiation, we must know the types of radiation. There are many types of radiation. Now, as you can see in the diagram, there are radio waves, microwaves, infrared, ultraviolet, visible, and gamma ray. And to further classify this radiation, we have three main measurements, which is alpha, beta, and gamma. If you can see in the diagram, the red zone of frequency, which is 10 to the power of 4 until 10 to the power of 12, is the alpha ray. And in the middle, in the colorful section, 10 to the power of 15 to 10 to the power of 18 is the beta, and 10 to the power of 19 and above is gamma, which is very dangerous, as we all know. Next, I will continue with the properties of radiation. There are three properties of radiation that we all must know, which is the reflectivity, absorptivity, and transmissivity. Based on the diagram too, if you can see, all radiation starts from above, which is the incident radiation. Incident radiation is the origin of any radiation from a medium to the medium we are trying to radiate. So, upon touching the surface of the object, the radiation will split into three based on the types of surface, whether it's transparent, semi-transparent, or opaque, based on its materials. Then the radiation will split either into either it will reflected, which is reflectivity, which is or absorptivity, and transmitted, which is the transmissivity, where the radiation passes through the object, which means that the object is really transparent. Next, to further continue the properties and other things, we move to Muhammad Nabil Najmi.
Hello, my name is Nabil. I will present you about properties of radiation that Nabil Haikal have presented before me. Okay, there are three types of properties of radiation. First, reflectivity. Second, absorptivity. And third, transmissivity. Sorry about my grammar, okay? Okay, there are three formula for this property of radiation. First, I will tell you the formula about reflectivity, okay? Rho equal to reflected radiation per incident radiation. So, reflected is the one, the radiation that were reflected by the substance, and the incident, the source of the radiation. So, by divide the reflected and incident, we get rho, the reflectivity. Okay. Second, for the absorptivity, alpha. Alpha equal to absorbed radiation over incident radiation. Absorbed radiation means the radiation that been absorbed to the substance or being absorbed by the substance. So, absorbed radiation over incident radiation will give a alpha absorptivity. Okay, understand? Okay. For the last one is transmissivity. Okay. Tau equal to transmitted radiation over incident radiation. Okay, transmitted is the one that pass through the substance, and incident radiation is the source of the radiation. By divide this this type of radiation will give us torque. For next one, the total radiation formula. Okay, G exhaustivity plus G reflectivity plus G torque equal to G yin equal to G. Don't be confused with the G. G mean radiation. Okay, so exhaustivity plus reflectivity plus torque equal dengan yin will give us total radiation. Okay, for transparent substance, there are some case study about it. So for transparent substance, the total radiation formula is alpha plus rho plus torque equal to 1. Okay, for opaque, non-transparent, transparent surface. Non-transparent surface means surface that the light cannot pass through it, such as cement, silicon, wood. Okay, the formula is exhaustivity alpha plus rho equal to 1. With some circumstance that torque is equal to 0, the transmitted radiation. So that's all from us.
Let's continue with the other topics.
Yeah.
Oh hi, I'm Liana.
And I am Stacy.
So today we're gonna explain about black body's radiation.
So, what is black body radiation?
Before we know to understand what is black body radiation, we have to understand how we see the object. We can see the object due to the reflection of light.
For example, this apple is red due to the reflection of red light, while the rest of the light has been absorbed.
But if the object is black, like a black box, all of the light, which is wavelength, is being absorbed.
Certain objects are called black bodies due to they absorb the electromagnetic radiation of all wavelengths.
All object radiates energy. When the object's temperature increases, the rate at which it radiates energy also increases.
Noting that the distribution depends not at all on the material, but on the temperature.
When we put more energy in it, it will turn yellow.
This is why a very hot object is glow like the sun, the bulb, and a hot oven. This is because this object at this temperature they emit a lot of electromagnetic radiation.
Like human body, we only have 310 Kelvin and emits essentially no visible light.
That's why we cannot see each other in the dark. Therefore, the increase in the absorbed energy leads to the emission of light of shorter wavelength.
But we have a problem. What if we increase the temperature more than this? Theoretically, if we continue to add more energy in the object, it will start to emit UV light and it become invisible. This is called UV catastrophe.
The person who saved this problem is called Max.
This Max.
Definitely no.
Oh, this Max.
No.
So maybe this Max.
Yeah, this Max.
Max Planck.
Max Planck come up with the concept of quantization.
Max Planck developed an equation for black body radiation, which is E equal to NHF. where E is the energy, N can be any integral, it can be 1, 2 or 3 and etc. H is equal to Planck constant, which is 6.626 times 10 to the power of negative 34 joule second. And F is the frequency of the radiation. Thus, this marked the beginning of the quantum revolution. So that's all from us.
Thank you.
Thank you. Let's proceed for the next topic, outside. Bye.
Assalamualaikum and good morning. My name is Muhammad Nazmi bin Muhammad Bukhari, and today I want to discuss about view factor radiation on a various geometry. Radiation heat transfer between surface depend on the orientation of the surface that is relative to each other, as well as their radiation properties and the temperature. View factor is defined to account the orientation on the radiation heat transfer between two surfaces, and view factor is purely geometry quantity and is independent on the surface properties and the temperature. As an example, from the surface I to the J, we call the Fij or Fi to the J, which meaning that the fraction of the radiation leaving from the surface I is to the surface J is the directly. And I will pass to the next member to next discussion.
Thank you, Nazmi, for your explanation. Okay, now we will move to my part. Okay, my name is Muhammad Farisha bin Hassan, and now I will explain to you guys about the value of view factor range. Okay, so in this explanation, they have three type of surface that we concern. For first, we have plane, we have convex, and we have concave. Okay, the view factor for plane, the Fij will equal to 0. For the convex, it will F equal to 0, and for concave, the value will be Fij, and it will not become 0. Okay, there are value factor of view factor range between 1 and 0. So the value of view factor are between 1 and 0. There will not be less than 0 or more than 1. So the range are between it. So when Fij equal to 0, the surface do not have a direct view of each other, while the Fij equal to 1, the surface J completely surround the surface. The next, we have a sphere. For example, we have inner space, inner circle and outer circle. So the F will be F. The inner surface, inner circle will become 1, the outer circle will become 2. So the F will become F1 to 2. Okay, the view factor is F1 to 2 is 1. It was because the entire radiation leaving surface of smaller sphere will become intersect by the bigger sphere. Okay, that's all from me. Thank you. And now we'll go to the next person to explain further for you guys. Thank you.
Assalamualaikum and a very good morning. My name is Muhammad Faris Faik, and today I will be presenting with my partner
Muhammad Zohakim bin Zulkifli.
and today we will be explaining on radiation shield.
Okay, so I'll be talking about the function of radiation shield. Radiation shield acts as a border between two surfaces that emitting radiation waves such as electromagnetic wave, microwave, even low frequency wave. So this radiation shield will act as a border and that will absorb or reflects the radiation from passing through and affecting the surrounding, such as us, the people. Therefore, the material to make this radiation shield must have two characteristics. First, it must have high reflectivity. Secondly, low emittivity. And next, we will be talking about the examples of radiation shield.
Alright, for the examples of radiation shield, there will be two examples. The first one is mobile phones. So for mobile phones, the frequency used in mobile phones are microwave frequency. Do you know what is microwave frequency? So microwave frequency is one of the frequency that could be harmful for ourselves. So usually mobile phones users can be affected by radiation and can cause them to have short-term memory loss, long-term memory loss, increase in blood pressure, and also brain tumor. So the function of radiation shield is to protect us from being contacted with the radiation produced by our surrounding. And the next example is in our chemical industries. In our chemical industries, we will be using machines and also equipments. And in these machines and also equipments, there will be heat loss. And these heat loss are produced by radiation. So, how do we reduce the heat loss to our surrounding? The answer is by radiation shield. Why radiation shield? Because radiation shield help us to reduce the heat loss, because most heat loss are produced by radiation. Therefore, there will be a constant heat loss by the machine, and also the amount of heat in the machine could also be constant and will not affect our specimen a lot. So next, we will be explaining on the formula of heat transfer.
Hi, I'm back again. As been mentioned by Faris, how to calculate the radiation heat transfer, which will be radiation heat transfer is actually energy, Q. And I have researched, I have three formulas. The first one, the second one, and the third one. Okay, all these three formulas have different manipulating variables, which consist of emittivity, reflectivity, the distance between the radiation shield and the borders, such as that. But they all have the same purpose, which is to calculate the energy, radiation heat transfer, the Q. Therefore, in conclusion, radiation shield have both pros and cons.
It's true. The pros of radiation shield is it could help us avoid all these harmful disease that could affect our body. So for cons, the examples of bad effects that might be harmful to our body is when we use lead as our radiation shield, because lead materials have about 282 molecules of electron, protons, and also neutrons. So these 282 molecules, when it is being struck by the radiation, it will disperse and it will hit the human's body. So when it hits the human's body, our body will be affected by the molecules and radiation. Therefore, it will be quite dangerous and harmful also to our body. I think that's all from us.
Yeah, so as we know, radiation shield, we have to know to choose the materials, the right material to make this radiation shield. I guess that's all.
Yep, that's all. Alright, thank you.
So what we can conclude is radiation is a type of transfer of heat, and there are three main properties of radiation, which is reflectivity, absorptivity, and transmissivity. And any type of radiation that certain objects are called black body radiation because they emit all types of wavelength at certain temperature. The wavelengths are alpha, beta, and gamma.
And radiation, as you can know, radiation is very harmful. Therefore, we must protect ourselves, protect the machine in the company, in the factory with what we call radiation shield. So the materials that they needed to make this radiation shield must meet the following characteristic, which is high reflectivity to reflect the radiance of the radiation rays, and also low emittivity, so that it can absorb and lower the transmission to pass through and affect the other objects of the machine, or even us, the people. So I guess that will be all from us. Thank you very much, and bye.
Bye.